Good afternoon, judges. Today, our group will be presenting on the use of recycled clamshells on water purification. Current rapid industrialization in developing countries has caused the natural levels of heavy metal ions to significantly increase in the last couple of decades. These heavy metal ions are non-biodegradable and are hence unfit for human consumption. For example, phosphate is a common pollutant which can cause eutrophication. In addition, crustacean shells are simply discarded after consumption, and this is a pity because these shells contain calcium carbonate, which may have the potential to remove both heavy metal and phosphate ions. Moving on to our objectives, we are planning to investigate on the effectiveness of various types of clamshell in removing heavy metal and phosphate ions, as well as the effect of pH on the removal of metal ions. Finally, we also created an eco-friendly water purification prototype that serves as a cost-friendly alternative for developing countries. Moving on to our method, first, we hammered the shells and blended it to powder form before putting 0.5 grams of it to 50 ml of 50 ppm metal ion solution. For phosphate ions, we first ashed the shells at 550 degrees Celsius to form calcium oxide. These shells roasted for 1 hour. Following, we filtered and analyzed the mixture to find the concentration of metal ion solution which remained, using a calorimeter for copper-2 and phosphate ions, as well as an AA spectrophotometer for lead-2 ions.
Moving on to our results for the removal of copper-2 ions at pH 2 and 5, we can see that at pH 2, removal by lala and blood cockle shells are significantly more effective than muscle, while at pH 5, all three types of shells show effective removal of copper-2, with percentage removal being close to at least 90%. Also, there is no significant difference between the removal of copper-2 ions by the three types of shells. Now, for the removal of lead-2 ions at different pH, we can see that all three types of shells are able to remove lead-2 ions, and the removal of lead-2 ions is more effective at pH 4 and 6, with the percentage removal of being close to 100%. Now you might ask, why are shells able to remove metal ions? After some research, we have found that clam shells contain aragonite, which is a biogenic form of calcium carbonate. Also, aragonite is able to swap its calcium ions in exchange for heavy metal ions by this process known as ion exchange. This can be seen from the equation as shown. Now moving on to the removal of phosphate ions, our results show that unashed shells are very ineffective. Hence, we have tried all means to increase its effectiveness and stumbled upon the method of ashing the shells. And as you can see, ash shells are very effective in removing phosphate ions, close to 100%. Now, based on our research, ashing the shells break down the calcium carbonate into calcium oxide. Calcium oxide then removes phosphate via precipitation. Moving on, the clam shells have an added advantage over commercial adsorbents, such as activated carbon and chitosan, as it is effective in acidic wastewater removing both copper-2 and lead-2 ions, while activated carbon is not. Generally, the clam shells are as effective as chitosan in removing metal ions. Similarly, clam shells are as effective as commercial adsorbents in removing phosphate ions.
We also compared the prices of our shells with commercial adsorbents. It can be seen from the table that activated carbon and chitosan are more expensive and not as effective as compared to the shells, which are practically free. On the other hand, we also compared our clam shells with commercial products such as calcium oxide in removing phosphate ions. Calcium oxide is effective as no pH adjustment is needed and only costs $3 per 100 grams. Our ash shells, though as effective, have an estimated cost of $2 to $4, and some costs are incurred during the ashing of the shells. Hence, we find this not practical and thus did not conduct further study on phosphate. Moving on to our prototype, we have packed a bottle with lala and blood cockle shells while excluding muscle, as muscle shells are generally ineffective. On my left is a diagram of our prototype, and here's our prototype. As the powdered shells are closely packed together, it has a large surface area for the removal of metal ions. Wastewater will be poured into the prototype and purified water will be obtained here. We have also conduct a test with our prototype, and it can be seen that it's effective with a percentage removal of almost 100%. Therefore, in conclusion, the removal of metal ions is better at higher pH. Lala and blood cockle shells are generally more effective in removing metal ions and phosphate ions. Clam shells also remove metal ions more effectively than activated carbon at low pH and is comparable to chitosan in the removal of metal ions. Lastly, our prototype can effectively remove heavy metal ions with percentage removal being close to 100%.